This is Advanced Math, Review Number 1, Worksheet, Homework Questions. Again, Advanced Math, Review Number 1, this is from Unit 12. Review Number 1, Worksheet, Homework Questions. And I'm going over a lot of them, because it was a pretty hefty review worksheet. And speaking of the review worksheet, I'm going to show it to you really quick. It's right here. I want you to cross out numbers 4, 21, and 22. You don't have to worry about those at all. Just cross them out. Be done with them. So this is review 1. Now there is a mess up on review number 2. This is review number 2, which is at the bottom of my website, but was not put in the original packet that students picked up. So options, choices. I'm going to make this review number 2 extra credit. If you've done it already, turn it in when you turn the packets in. Extra credit. If you haven't done it, you do not have it, don't worry about it. It's not going to count against you. If you picked up a packet and you do not have one of these because it wasn't in there, you can print it off my website. If any of you guys have friends that you know do not have access to my website, will you please let me know or let them know, send them a picture of it, whatever they can do so that they have access to it if they wanted to. All right, so I'm going to go over this. Again, that's the review that's in the packet. It's on my website. It's part of the worksheet packets. It's the last worksheet before the answers. Okay, so starting off with number 3. I believe that is true, false. True, false goes up to number 7. So the first few are true, false. Starting off with number 3. The graph of f of x equals 9 to the negative x goes down as x increases. Goes down as x increases. Okay, so kids freak out with this. Oh, what am I supposed to do? You just need to know what the graph looks like. I'm just going to change that to y. 9 raised to the negative x is 1/9 raised to the x. And I've said before, what you need to know is whether this is an increase or a decrease. If the x is positive, the exponent is positive, which it is, and the base is smaller than 1, it is a decrease. It's not an exponential growth, it's an exponential decay. Okay, so why is it a decay? Because my exponent's positive and my base is bigger than 1. All right, so it's going down. So now let's answer the question. Does this graph, does it go down as x increases? X increases to the right, it gets bigger to the right and smaller to the left, just the x values. It gets bigger as we go to the right, 0, 1, 2, 3, 4, 5, x is getting bigger. As x gets bigger, does the graph go down? Yes, that is true. As x increases, as x gets bigger, the graph goes down. The graph is decreasing. Yes, that is true. Okay. Moving on to number 5, log base b of m plus n equals log base b of m plus log base b of n. Now this is pretty much asking, are we allowed to distribute? Can I distribute log base b to get this? No, we never do. That is a big fat false. Now, we do have something for this, not for the one over here, but this one here. When I have two separate logs that are being added and they have the same base, that I can write like this, log base b of m times n. That's a log law. But that still does not equal this, so it is still false. False. Okay, number 6. Number 6 reads log base b of m over log base b of n equals log base b of m minus log base b of n. Okay, so when I have subtraction, subtracting two logs at the same base, do I change it to a fraction? Well, let's think about it. We do, I'm going to use this side here, we do. But when I change this to a fraction, it looks like this, log base b of m over n. I write it as a single log of a fraction, which is not the same thing as a fraction with two separate logs. So this is also false. Why? Because when I make it a fraction, it looks like this. A single log of a fraction, not a fraction with two separate logs. So that is also false. Number 7, log base 5 of 2 minus log base 5 of 10 equals -1. All right, I'm going to use my log laws on this side because it is two separate logs with the same base being subtracted, so I can change that to a division problem. Looks like this. Log base 5 of 2 over 10. We're going to check if it equals -1. I'm going to reduce that. Log base 5 of 1/5. And I'm going to wrap around and see if that works. 5 raised to the negative first power equals 1/5. Is that true or false? That's true. So it works. Number 7 is true. Okay, next one is number 9, and I believe number 9 is not a true-false question. Number 9 is if log of 2 equals c, then log of 20 equals c plus 1. Okay, if log of 2 equals c, then log of 20 equals c plus 1. Okay. Oh, this one's also a true-false. Okay, so true-false goes up to number 10. So, is this true or false? I'm going to work with this. We know log of 2 equals c. Can I write 20 as a 2? Log of 2 times 10. Okay, 2 times 10 is 20. And I am going to erase that and move it over. Start over. Okay. If log of 2 equals c, then log of 20 equals c plus 1. Okay, so I'm going to write it over here. Log of 2 times 10. Log of 2 times 10 is the same as log of 20. We agree with that. 2 times 10 is 20. All right, I'm going to use my log laws. Log of 2 plus log of 10. Now that's nice because log of 2 equals c. So I can take that log of 2 and replace it with c. Plus log of 10, there's no base there, which means it's base 10. Log base 10 of 10 equals 1 because 10 to the first power is 10. So log base 10 of 10 equals 1, therefore it equals c plus 1, which is that, so that is true. Okay, and last true false, number 10. Number 10 is 3 to the x plus 3 to the x plus 3 to the x equals 3 to the x plus 1. Now, just at first glance, we're like, heck no, that doesn't work. That's false because they're not like base. They are like bases, but they're not being multiplied. Okay, but remember, we've used u substitution for these types of problems. So I'm going to do that now. I'm going to let u equal 3 to the x power, which gives me u plus u plus u equals 3 to the x plus 1. U plus u plus u is 3u. I'm going to plug the u back in. 3 times u is 3 to the x. Now I'm multiplying like bases, which means I add the exponents. 1 plus x. So I have 3 to the 1 plus x. Does that equal 3 to the x plus 1? Addition is commutative, which means these two things are the same. So it is a true. All right, number 12, follow directions to find the requested information. If log base 4 of 16 equals x squared, then solve for x. So solving for x is what we're doing. Now I have a log and I want to get rid of it. It's either drop the log or wrap around. Both drop the log and wrap around will get rid of a log. In this case, it is a wraparound because there's not a log on the other side. So we have 4 raised to the x squared equals 16. All right, I want to get them to have the same base. I could use base 2 or base 4. They both would work. I'm just going to stick with base 4. And 16 is 4 squared. You guys see how that works? 16 is 4 squared. So I'm not changing its value, just the way it looks. And this side stayed exactly as it is. Since they are both the same base, I can drop the bases. X squared equals 2. And inverse operation is square root. And when I square root both sides, I do plus or minus. Therefore, x equals plus or minus root 2. And that is it. Okay, moving right along, I am going to move on to number 16. Says if log base 7 of n equals 0, then what is the value of n? So we're solving for n. All right, I have a log. I want to get rid of it. I either drop or wrap around. Since there's only one log, it is a wraparound. 7 to the 0 power equals n. 7 to the 0 power is 1, so n equals 1. Okay, next one I have is 24. And on 24, it asked us to simplify log base 2 of, I'm going to rewrite that part, of 4 times 256 over 16 squared times 8 cubed. Okay, first thing I recognize is that they all have a common base of 2. They all could be written with the base of 2. So that's the first thing I'm going to do. Log base 2 of 4 is 2 squared times 256 is 2 to the 8th. You can check that on your calculator. 16 is 2 squared, and then the squared is still there. 8 is 2 cubed, and then the cubed is still there. Okay, so 2 squared, and 2 cubed, cubed. All right, I'm just going to simplify the one at the top. This is log base 2 of like bases, so I'm going to add the exponents. 2 to the 10th over, this is, I multiply, so it's 2 to the 4th times 2 to the 3 times 3 is 9. Whew. Log base 2 of 2 to the 10th over, now I'm going to add the exponents. 2 to the 13th, nope, yes. And I messed up somewhere, and I did right here, and I apologize. You're probably thinking, what is she doing? 2 squared is 4. I need it to be 16, so this should be a 4th power, which would change this to an 8th power, which would change this to the 17th power. Now we're back on the right track. Whew. Okay, so 16 is 2 to the 4th, not 2 squared like I originally had. 2 to the 4th, we multiply our exponents. 4 times 2 is 8, 3 times 3 is 9, and then we add and we get 17. Whew. Log base 2 of, I can subtract exponents because they have the same base. And since there's more at the bottom, it's going to stay at the bottom. Actually, I'm just going to make it negative. 10 take away 17 is negative, so 2 to the negative 7 power. And then we do the wraparound. And I'm going to set equal to x. 2 to what power is 2 to the negative 7th? X is going to equal negative 7. So this simplified is negative 7 as an answer. That was a heavy one. So 24 asked us to simplify, so simplified is negative 7. I'm going to erase the x because there was no x there to begin with. In simplified form is negative 7. All right. I'm moving on to number 25. 25 is given log base 4 of 8 plus 2x equals 1/2, and they're asking us to solve for x. There's a log, I need to get rid of it. I either drop the log or wrap around. Both of those will eliminate the log. This is a wraparound since I have only one log on one side. There's not a log on the other side. So 4 to the 1/2 power equals 8 plus 2x. 4 to the 1/2 power is the square root of 4, which is 2. And I'll let you guys finish from there. That you can solve. Subtract, divide, you get an answer. Okay, moving on. The next one I have is number 26. And 26 is log base 5 of log base 3 of 2x equals 0. Kind of hefty, log of a log, which we can do. Again, we're trying to get rid of the log, and it's a wraparound because there's only one log. Don't worry about the inside. There's a log on one side. There is not a log on the other side to do a wraparound. Now, if you wanted to, you could change that to a log, if you wanted to, log base 5 of 1, and you would end up with the same answer. All right, I'm going to treat it as a wraparound. 5 raised to the 0 power equals that piece there. So that gives me 5 to the 0 equals log base 5 of 2x. 5 to the 0 is 1. Now I'm trying to solve, and there's still a log. So I'm going to wrap around again. 5 to that power equals 2x. So 5 to the power of 1 equals 2x. 5 to the first power is just 2. Divide both sides, and you get, and is that 5 or base 3? Because it looks like I have something. Nope. Okay, so 5 over 2. And nope, it is a 3. And that's what I get for going too fast. This is a 3. That is a 3. A 3. And where am I at? 3 to the first power. And I apologize for rushing through. Divide x equals 3 over 2. All right, next one is 30. And number 30 is 4 times log base 2 of x minus log base 2 of x plus 2 equals log base 2 of x squared. All right, I'm going to solve. First thing I'm going to do is bring that 4 up as a power. I'm going to do it at the same time. I'm going to bring that up and change it to a fraction, to a division. Log base 2 of x squared over, I'm sorry, not x squared, x to the 4th, don't rush, x to the 4th over x plus 2. So because they have the same base and it's a minus, I'm condensing it to a single log as a fraction, but I brought that up at the same time as a power. Now, is this drop the log or wrap around? Both of those will get rid of your log. Since there's a log on each side, it is a drop the log. So x to the 4th over x plus 2 equals x squared. And I am going to multiply both sides by x plus 2. And distribute. X to the 4th equals x to the 3rd plus 2x squared. I'm going to subtract that over so I can factor and solve. And I end up with this. Now I'm going to GCF and x squared. That gives me x squared minus x minus 2 equals 0. X squared, double bubble, x plus, x minus. It looks like minus 2 plus 1. Is that right? Negative 2, negative 1. X equals 0, negative 1, and positive 2. And let me check. I'm dealing with the log. And right here, I have to check anywhere there's an x. I'm going to have to check it here, here, and here. And if it's, I cannot take the log of a negative or log of 0. If it's negative on any of them, I cannot do it. I don't have to check the rest. For example, right here, if I plug in negative 1 plus 2, that's positive. But here, it's going to be negative. Log base 2 of negative 1, I cannot do, so 2 is not going to work. You cannot take log of 0 either. So 0 plus 2 would work, but right here, log base 2 of 0 is not going to work. All right, let's try 2. Log base 2 of 2 would work. 2 plus 2 is 4, that would work. 2 squared is positive, that would work. So x equals positive 2 is our only solution. 0 and negative 1 were extraneous solutions. All right. Moving right along, my next one I have on my list is 31. And 31 is similar to one we've done in notes. It looks like this. Oh, that is a cube root of 5 equals 10 minus ln of x. And if you remember in notes, I brought the ln's to the same side, and I brought that 3 up as a power to both the top and the bottom of that fraction. So ln of e cubed over the cube root of 5 cubed plus ln of x equals 10. All right, I'm adding two logs with the same base. I'm going to condense it with the multiplication. ln of e cubed over 5, because inverse operations undo each other, times x over 1. You don't have to put over 1. I'm just making a point that it's there. And I'm going to, now I'm just going to write that as a, well actually, no, I'm going to solve it. Is this a wraparound or drop the log? There's only a log on one side, so it is a wraparound. What's the base that we don't see? It is e. So that gives me e to the 10th equals e cubed x over 5. And I'm trying to solve, so I'm going to multiply both sides by 5. Gone. E cubed, nope. 5 e to the 10th equals e cubed x. I'm going to divide both sides by e cubed to get x by itself. X equals, and since these two are like bases, I can subtract. 10 take away 3 is positive 7, so 5e to the positive 7. Now if you wanted to, you could plug it in your calculator and get a decimal. I'm going to leave my answer like that. 32 is my next one, and 32 reads 2 to the x plus 4 times 2 to the negative x equals 5. I'm hoping you recognize at this point that these are kind of like those U substitution problems that we've been doing. I'm just going to rewrite this as 1 over 2 to the x. Can you see how that is the same thing? A negative exponent moves it to the bottom. So I'm going to put a u in. I'm going to let u equal 2 to the x. I'm going to plug it in. U plus 4 over u equals 5. 4 times 1 over u is just 4 over u. Multiply everything by the u to clear it out of the denominator. 4 times, I'm sorry, u times u is u squared, plus 4 over u times u is just 4 equals 5u. Subtract it over u squared minus 5u plus 4 equals 0. And now you are ready to double bubble, factor, and solve. Factor that on your own. I can tell the two signs are going to be the same. The negative in front of the 5 tells me they're both negative, and I'm going to use 4 and 1 to give me the negative 5. U equals 4, u equals 1, and I'm going to plug the u back in. 2 to the x equals 4, 2 to the x equals 1. These are easy to solve because I can get them to the same base. 2 to the x equals 2 squared. 2 to the x equals 2 to the 0. Therefore, x equals 2 and 0. Now, just a really quick side note. I'm going to erase this, but let's just say, actually, I can probably leave it there. Let's just say our answers came out to be 5 and 1, and we had 2 to the x equals 5 and 2 to the x equals 1. This one would be easy to solve. That's 0. This one here, this does happen at times, especially like on tests and quizzes and even sometimes on worksheets. You can't get them to the same base. So that's where you would do log of both sides. I'm not going to work this one all the way out, but you bring your x down, divide both sides by log of 2, and work it out. So I'm bringing that up because this one came out to be nice and pretty where you can get them all to the same base, but life does not always work out that way, and if it doesn't, we have tools to solve that as well. Okay, that is 32. I am moving on to 37. And 37 and 38 kind of go together. So before I write down 37 and 38, I'm going to write down the given information. If log of 2 equals c, find the following. 37 log of 80, and 38 is log of 1/5. All right. Now, remember when you have these, you always have your should know. Your should know in this case is log base. What base are we using? Oh, base 10. Log base 10 of 10 equals 1. So we can use 2 and or 10 using, remember it was multiplication, division, and exponents. Okay, so let's see. Log of 8 times 10 is 80, and I'm using 10 because that 10 is there. And 8 is 2 to the third. 2 to the third times 10 is 80. And now I cannot plug anything in yet because 1, I haven't used my log laws. 2, nowhere do I have any. Log of 2 is just log of 2, not log of 2 cubed times 10. I have to get log of 2 by itself. Log of 2 cubed plus log of 10. And I'm still not ready to plug in the c because I don't have a cubed over here. I cannot just throw it in there. So I have to bring my power down, and it's 3 log 2 plus log of 10. So now I can plug it in. 3 times log of 2 is c, so 3c plus log of 10 is 1, 3c plus 1. And 38, okay, I can't use a 5. I can use 10 or 2, and I can't use 1 or 5, so I'm going to try to change that fraction. I'm going to multiply top and bottom by 2, and if that doesn't work, I'm going to multiply top and bottom by 3, by 4, by 5 until I get it to work. 1 times 2 is 2, 5 times 2 is 10, and there we go. There's a 2, there's a 10, I'm ready to work it out. And you should agree that 2/10 is equivalent to 1/5. They're equivalent fractions. Log of 2 minus log of 10, you're not ready to plug it in and say, oh, c over 1. You cannot do that. You have to separate them first. C minus log of 10 is 1, c minus 1 is the answer. All right, I'm going to squeeze number 40 down at the bottom. Okay, 40 is asking what interest rate is needed to triple an initial investment within 8 years if the investment is compounded continuously. So we know we're dealing with the PERT because it says compounded continuously. And it's asking what is the interest rate. So right off, we know we're looking for R. What interest rate is needed to triple an initial investment within 8 years? So time is 8. That's all it gave us. And triple the amount. So remember, if they tell you triple the amount, double the amount, half-life, quadruple, whatever it is, but they do not tell you the initial. Your initial is always 1, and your ending amount in this case is 3 because we're tripling. If it said how long does it take or what is the interest rate to quadruple the amount, P would be 1 and A would be 4. What is the half-life? P would be 1, A would be 1/2. Whatever the problem is asking, whatever it takes, double, triple, quadruple, P is 1 and A is 3 or 4 or 2 or half, depending on the problem. Okay, we are ready to plug it in. A is 3, P is 1, E is just a number in your calculator, we don't know R, and T is 8. It's not necessary to divide both sides by 1 because 1 is a multiplicative identity, but I'm going to divide it. 3 equals e to the 8r. E is a number in my calculator, but I can't raise it to the 8r because r is a variable, and that's what I'm looking for. So is this a wraparound? Drop the log or take the log of both sides. Where's my variable? My variable is an exponent, and the only way to bring it down is if there's a log there. I cannot bring it down right now the way it is, so I'm going to take the log of both sides. Now, because it's e, I'm going to do ln of both sides, which is just a log with the base of e. All right, now the whole reason I do this is to bring this to the front. Ln of 3 equals 8r times ln of e. And remember, we've done this a few times, ln of e is just a big fat 1 in disguise. Why? Because log base e of e is 1. Okay. So I have ln of 3 equals 8r, because ln of e is 1. Divide both sides by 8, and you would plug that in your calculator. Ln of 3 divided by 8 equals 0.137. So my interest rate is 13.7%. You can write it either way. I like to write it as a percent. 13.7% is the interest rate I would need to quadruple any amount in 8 years. Any amount. Doesn't matter what that amount is. If I want to quadruple it in 8 years, compounded continuously, the interest rate would need to be 13.7%. All right, that is it for this section of homework questions.